gotta speak softly so I don't wake up the cat. When I was rewatching this layman's guide to data center fiber optics, I don't think I really covered loopbacks well enough, so I will do so right now. I used to really be afraid of loopbacking. I didn't understand it. I didn't know the value in it, but it's actually really, really nice to have. So, for it to understand, because you're going to use it a lot. Like at my new job, I use it a lot. So, in simple terms, if you have a link between, let's call this switch 1, and then you have switch 2, and on switch 2, you have port 2, and this is port 1, right? I have fiber, or copper, or whatever you want to call it, but let's go with fiber. If I have fiber connecting these two switches together, I usually will have a little device that plugs into the port known as an optical transceiver. They come in many different models, shapes, bandwidth sizes, speeds, but typically when a link does not work, it's for the following reasons, and these are the reasons in order of appearance that I've seen in my experience. 1. Bad optic. Optics go bad a lot. They have to transmit, they are in a port, and either the port does this or the optic does this. I keep forgetting. I'm pretty sure it's the optic itself that does it. They transceive or translate digital data into fiber optic light data that can be read and transmitted over the thousands of glass bristles that exist within a fiber. So that way they can go to another switch, which then gets translated from light to digital, and that generates a lot of heat. And that heat can result in optics going dead, or not being able to continue their function. 2. Bad fiber. Now, bad fiber is more rare, but when this occurs, you have multiple symptoms, and you can actually go into this video that I have here and it'll explain it more. But 3, and this is something that you have to prove, especially before you escalate it to some other team, is bad ports. Right? Now, you can test all 3 of these things with a loopback. So let's just look at switch 1, for example. Gotta make my image bigger. Let's look at switch 1. So in switch 1, we have port 1, right? And in port 1, we have the optical fiber, or the optical transceiver. Let's just call it an optic, right? And then we have the fiber itself. You can have a loopback device attached to the optic. Let's stop there. What's the point of looping the optic right here in switch 1? Well, most switches are smart enough to tell you that whether or not an optic is up or down, and switches are also smart enough to tell you that the port itself detects its own data as looped. So if you have a port that has an indicator light, for example, right? This indicator light is dark. That means that the port is not up. It's not sending data or it's not receiving data, the link itself is dead. But if you simulate a working link with a loopback, you can get this to show up. Now, if you get this to show up, this proves two things. One, it's not bad port, because the port itself can work. Two, not bad optic at switch 1. Let me spell that. Because if you had a bad port, it wouldn't come up. And if you had a bad optic, it wouldn't come up either. If it was a dead optic, essentially a brick, this loopback would not this port would not see its own transmission signals, or it wouldn't transmit anything because the optic itself is bad. If the port itself is bad, it wouldn't be able to send data or read it itself, even if the optic is good. Even if you put in a new optic to do that, to test it, it wouldn't, you can't really prove it. You don't have to get a new one just yet. You don't have to even test with a new one just yet if you just throw in a loopback. If you throw in a loopback and everything's hunky-dory on switch 1, then you know that the problem lies somewhere else. Now, here's the question. You have the switch 1 side of the fiber that's already there, and then you have the switch 2 side of the fiber that's already installed, right, in the system, in the data center, in the network, right? If you want to loop back to test this fiber, where would you put your loopback? Now, some people work like this. They show up to switch 1 for the first time, and because they're richy rich and they have 2 loopbacks, they can put a loopback on the transceiver to test switch 1, the port for switch 1, and the optic, and they put a loopback on the switch 1 side of the fiber to test the fiber. Now, if this test shows that the fiber, or if your loopback here doesn't result in switch 2's port showing up, that doesn't mean that it's the fiber. And that's what's treacherous about immediately putting 2 loopbacks on. How I work is I would like to prove that one side is good. Because if I can prove that one side is good, I can test the fiber. And here's how. Let's rewind to this point. So this is the switch 2 side of the fiber that's installed already. And this is the switch 1 side, obviously. I've just proven that switch 1 is good, the port for switch 1 is good, and the optic for switch 1 is good. I want to prove that the fiber may or may not be bad. And I can actually prove this with a loopback, but not here, as most would jump to do. I'm going to put a loopback here and run a loopback test if I have to. Most of the time what will occur is that I'll be able to SSH into switch 1 and analyze the state of port 1, right? Because this is port 1. And if it shows that port 1 is up and looped, that means that the fiber itself is okay. Now, that means that the fiber itself is okay enough to get a port up. It doesn't mean that it's okay enough to transmit an adequate level of light. Keep that in mind. However, it is enough to get the ports up. But the importance of putting the loopback on this side, on the switch 2 side, is because I've already proven that this side is good enough to test the fiber with. Don't jump to put a loopback on this side here, because you don't know if switch 2 is good enough to use as a test mechanism. You don't know if switch 2 is bad, or the optic there is bad, or the port is bad, but I know that switch 1 side is good, so I'm going to use switch one side as the tech mechanism by putting a loopback not on the switch one side, but on the other side. Think about it this way. And here's how I always thought about it when I was at AWS. Because our web UI, if you wanted to run a test for loopbacks, you would actually have to choose which switch to run the loopback test on. So it really made you understand this concept better. If you put a loopback here, and you run a command on switch 1 to test this port for loops, you're basically telling this switch here to send data along the fiber, have it loop around, and then send it back. And if it can receive it and the port gets up, the test passes. And what this proves is that the fiber optic itself is good enough to get a port up. So now I have to point all my questions towards switch 2, the optic on switch 2, and switch 2's port. I would just do the same test that I did on switch 1. And you can actually do both tests at the same time if you're working as a team or something like that. But if you're doing a solo job and you take enough notes to eventually make this a semi-automatic ingrained sort of methodology in your head, so that way you don't have to list it out all the time, it will help you so much to diagnose the weirdest problems in fiber optic networking. And this is also the case if you're regardless of media. It doesn't have to be fiber optics. You can put loopbacks on RJ45 copper cabling, Cat6e copper cabling, you know. And if your network is more complicated, like let's say you have patch panels here, and this is what I'm mostly used to this sort of structure, right? I'm used to a structure where you have a switch and you have a port and you have an optic on a port, and that optic on the port has fiber, right? And then it runs into a patch panel, which then goes into another segmented strand of fiber, which then runs into another patch panel. Hold on, wrong color. Which then runs into another patch panel, which then runs into another segmented strand of fiber, which then runs into another optic, and eventually goes to another port, another switch. Testing with loopbacks and fully understanding where to put a loopback on this side of the patch panel, on that side of the patch panel, on the side of the patch panel with an optic that works. Is it this segment of fiber that's bad? Or is it this one? Or is it that one? Like, these are questions that you have to ask yourself because of the fact that it could be all of the above. The worst part of loopback testing is when you can't find an optic that actually works, or you can't find a port on either side that actually works, and that loopbacks are not the way to go. At that point, you might have to choose a different port on a different switch to see whether or not this entire network is working right, or do a full audit of all the fiber that's deployed within these links. And those links, those scenarios are few and far between, and cause a lot of tears. The worst one. Here, I'll give you a real life example of architecture that I've seen. So, at the company I was previously with, we had a rack, right? And that rack had either a switch or two, but let's say it had a switch. And that switch took direct DAC cables, like copper cables that are 100 gigabyte bandwidth, and converted them into like 5 fiber optic links, right? But for now, we're just going to operate with one link, right? That one link among 5 would enter a patch panel that's on the top of the rack, right? Now, we would call this segment short fiber. And short fiber is a relative term because the middle segment was known as long fiber, right? And then this long fiber would end up in a really big patch panel. And that really big patch panel would connect the long fiber. Let's call this long fiber. The long fiber would connect another strain of short fiber to another switch, but this switch was really beefy, right? And it would be a whole rack of switches, just a whole bunch of these switches, these giant aggregate switches, because it was a huge data center, right? So you'd have a giant rack. We would call this rack a brick for good reason. And this entire rack's worth of switches would have all this fiber, right? So you have another short fiber, we'll call it that, right? And this just represents one link out of 5 from this rack to 5 ports here, and they all get aggregated into like a broader network. And I talked about in this video about the idea that within data centers and most networks, you go from a whole lot of servers to less switches that aggregate them to even less like switches that aggregate, and then eventually it turns into like a bundle of fiber that gets sent out of a building after it gets DM'd or something like that. But let's go back to fiber for a second. So we're here, right? This is your topology, and you would get a ticket that that cuts in and says like, hey, this link is down for some reason, right? And we may or may not tell you which side is actually down, right? So it's like, okay, well, is it the optic here? Is it the switch here? Is it the port here? Is it the short fiber? Is it the long fiber? Is it the short fiber here? Is it the port here? Is it the optic here? Is it the switch here? These are questions that you have to determine. And although this looks complicated, all you have to do is break it down into simple components of what could potentially be bad, how can I test it, and usually you test it with a loopback. And I was really inept, because back then what I would do is the second it would turn into a, hey, I need to get a loopback to test it, I would drop the ticket. I would not work on it. And the people that were more adept, but also more daring, I would say, or confidence to go and do the unknown and actually sit down and learn this stuff, would just go and easily find out what issue is it. Oh, it's the short fiber here. Boop boop. They would run it, and done deal. And I've only seen on a handful of occasions, like maybe less than 10 times, that it's ever been the long fiber. But you really don't want it to be the long fiber, because like this rack could be on like row A, and your brick could be in like row G, and you're gonna have to like run all this fiber across a basket, make sure there's no kinks and no sharp bends and everything, and then reconnect it. And it was just so bad, so bad. I mean, there's some data centers that just have terrible fiber hygiene, and the ones with bad fiber hygiene would have more long fiber issues resulting in problems. And you know, fiber optics degrade over time too. And most of the time, if your link is actually up, it could be a reseat fix. It could be you just clean dust off of it. Sometimes, and there's a better illustration than I can ever give you, but if you have a patch panel, and you have the nodes, this is like really nerdy. Right? Let's say this is the fiber. I love this stuff because this is like cutting edge shit. Like, this is the internet right now. This is what it is. You know, that's the backbone of it. Right. So if you have 2 fiber, you would imagine that the cores of the fiber would be like this then, right? Now, the actual light goes across the fiber, and it's a gap of a couple nanometers, right? And even though these things are plugged into the port, sometimes there's a shift that occurs where they're not in line with each other. They're actually like, let me see if I can do this. They, like, one optic or the other, not optic, I'm sorry, one strain of fiber or the other one will shift downwards within the port. So it's in the port. It looks like to the naked eye, it's like, okay, this thing's plugged in. It's not like the last guy left it plugged in. It's just shifted within the port itself, because plastic, you know, deforms and hardens and expands with heat and temperature and humidity. You know, there's a lot of variable factors on something that's actually as simple as connecting fiber together. And obviously, you don't want to run one giant connection of fiber for your entire network for every link because it's prone to failure. Um, and if it is prone, you don't want to rerun all that shit. Like patching, like segmented networks. This this architecture here makes a lot of sense from a maintenance and redundancy perspective. Um, but shit like this can happen, and most of the time, the only fix is to reseed it, and that's where you get like the really weird, like, all I did was reseed the optic and it fixed everything kind of thing, and it's like all I did was reseed it 5 times, and on the 5th time it worked, and on the 6th time it didn't, and on the 7th time it worked, and I stopped touching it. And like weird shit like that can happen too. But loopbacking is your bread and butter, and understanding it well is gonna give you a really good leg up on any sort of challenge that comes into your plate when it comes to figuring out and diagnosing fiber optic issues or any sort of networking issues, regardless of where you work, whether it's data centers or IDFs or small business networking or otherwise. Buy a good loopback. Don't cheap out on loopbacks. You never want to second guess your tool. Um, you can second guess yourself, you can second guess your methodology, you can second guess the equipment that you're testing, but you can never second guess your tool, because the second you do, you can start losing your fucking mind. It's not as bad as they say it is, but I hope the concept is expressed well. Have a good one.